Hey, there you are. Come on in. Have a seat. Have a seat. I got your coffee right here. So, last time we gave our application some memory, and then we gave it a home, and now we've learned that our database has tables, relationships, indices, and transactions. So now we've got another problem. Our cafe needs customers. So I'm not just sitting here staring at a database. We need real customers. Um, they need to be able to open the website, see the coffee and food, place an order, and have it delivered. So, um, our little cafe application is going to be turned into a web application. And this is where I want to introduce you to something that you've probably heard about, Spring Boot. Now, why do we need Spring, you might ask? So it's a good question. Because before I show you a single annotation, I want you to think about what it is that we've already built. We've got classes, we've got an inventory, we've got database, and we've got business logic. Now we're going to add a web layer to that. So imagine we have our customer come into our web controller, go into our order service, down to our product repository, which is our SQL database. And the customer makes a request, the controller receives it, the service layer decides what needs to happen, and the repository talks to the database. Simple enough. Here's the problem. Who creates all those objects? Who creates the controllers, the service, the repository? And how does the controller get all of the services that it needs? You could do it all yourself, and technically there's nothing wrong with that. But now imagine 50 classes, 100 classes, 500 classes. Suddenly, your application is spreading. And a lot of the time, worrying about how to construct itself. And that's where Spring comes in. So, Spring introduces a concept called Inversion of Control, or IOC. And it sounds much easier or much scarier, sorry, than it actually is. Normally, your code controls object creation. You would say new product service, provide the required arguments, and you create the object. With Spring, you hand that responsibility off to the framework itself. We are basically saying, um, Spring, you manage the objects for me. And Spring's application context becomes the container responsible for managing those objects. Those managed objects are called beans. And that's the word that you're going to hear constantly. Bean. Don't overthink it. A bean is essentially an object that Spring manages inside of its container. How does Spring know what to do? Well, we can simply tell it. So for example, if we had a product service, we could slap on at component. And Spring sees the component during an application startup and registers it as a bean. Now there's a few others that we can do that are a little bit more specialized. You might see things like at service for business logic, at repository for persistence related components, or even at controller for web-based controllers. Now, these are all ways of communicating intent. We're basically saying, Spring, this class is a part of my application. Please manage it for me. And there's also other ways that you can do this. We can be explicit by creating a bean ourselves. We can do so by saying something like product service, return new product service, and we tag it as a bean. Now, this gives us more explicit control over how that object gets constructed, but we still got a problem. Remember our controller? It needs a service, the service needs a repository, and the repository needs access to the database. That is a chain of dependencies. And instead of the controller doing all of this manually by doing service equals new product service. We can simply say that the product controller, private final, product service, and contract that in our constructor. And then Spring sees that constructor and it says, oh, there's a controller that needs a product service. I've got one of those here that I'm managing. Let me throw that into here. And that is what we call dependency injection. The dependency is simply supplied to the object instead of the object creating the dependency itself. And that is an incredible, important distinction. You may see people write something like product service with a little auto wired annotation there. That is field injection. And you'll see this in plenty of tutorials, and I don't want you learning it as default. I'd rather you use constructor injection because now the object tells us exactly what it needs to exist. And if a product controller requires a product service, you can't really construct one without the other. And that is good design. The dependency is explicit and it is immutable if we make it final. And this is much easier to test because we can simply provide the dependency ourselves. For example, some sort of fake product service, and no Spring required. That's one of the big advantages of dependency injection. It reduces coupling. Now, let's say our cafe eventually has two payment processors. We're handling cash, and now we're introducing credit card. So both of these implement payment service, and Spring now has a problem because you can ask it to give me a payment service, and it's going to turn around and say, huh, which one, bro? So this is where we have things like at primary, where we can tell it this is the primary source, and otherwise we can say at qualifier, and we can, tell it that this lets us explicitly identify which bean that we want. So we can use primary to tell Spring which implementation should be preferred, and qualifier lets us explicitly identify other beans that we want. So again, the important part is not memorizing the annotations, it is understanding the problem. I've got multiple objects that need satisfying with the same dependency. Which one should I inject? So now let's zoom out a little bit, um, because we're talking about Spring creating objects, but what's actually happening? Um, when the application starts, Spring creates an application context, and that context becomes the environment where our beans are registered and managed. It discovers components, it produces configuration, or it processes configuration, it figures out dependencies, it creates the objects that it needs, and it wires them all together. So instead of our application looking a little bit like controller has new this, new this, new this, we come up with something that looks a little bit more like this. And Spring is managing the object graph for us, and that's really what the IOC and DI are actually buying us. Now, here's something people often skip when they're learning Spring. The objects don't just magically appear. No, beans have a life cycle. Spring starts building the application context. It discovers the beans definitions. It creates and wires the dependencies, and then it applies various post-processing steps. And eventually, your application is ready to receive requests. Now, you can hook into this life cycle. For example, inside of an entity, you can use post construct, or inside of a bean, post construct, which allows you to do some sort of initialization work after it's been constructed. You can think about this as having like a class initializer after it's been constructed versus a constructor. And then you can have something that is going to happen when the bean is destroyed. So pre-destroy. Um, this just is some cleanup work. And these are also being they're being post processors that allow Spring infrastructure to inspect and modify beans during their life cycle. And that is one of those places where Spring starts revealing just how much machinery is underneath those simple annotations. The bean's scopes are not every bean has. Okay, so not every bean behaves the same. Okay, so by default, Spring beans are genuinely singleton scoped, meaning that Spring Manager um, Spring manages one shared instance of that bean within the application context. There's also prototype. This is where Spring creates a new instance every time that it's requested. And in web applications, you can also have a few other scopes tied to a request or session. So you have singleton, prototype, request, and session. These aren't just vocabulary words. They're telling Spring how long should this particular object live. And again, we're starting to see a bit of a pattern. Spring isn't really creating objects. It's managing the life cycle of our application's object graph. Now, let's say your cafe needs to run under different configurations. Um, so maybe we have a cafe name, a delivery radius, a maximum order size, a database location, and we don't want to hard code that stuff into our classes. Instead, we want to put these inside of a configuration, such as an application.properties or application.yaml. For example, we may have something like cafe.name equals midnight cafe. We may have something like cafe.delivery hyphen radius is equal to 15. And Spring Boot can then make use of these available options through values. And you may see at value, and then inside the parentheses, you'll see a reference to the name in the application. So cafe.name. But when you have a group of related configurations, such as the name, display radius, yada, 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 um, because instead of sprinkling individual configurations throughout your application, you can actually bind these to a single property within a Java object. Okay, so let's say we have cafe properties. It's Java record, and it contains a name and a delivery radius. Notice how the hyphen spaced words are now camel cased like Java. Just notice that. Okay, so we can tell this at configuration properties that it's going to have a prefix of cafe inside of the application.properties. And anything that persists cafe with the variable names, cafe.name, cafe.delivery hyphen radius, now configuration becomes something that our Java code can easily reason about as a type, which is much nicer. Now, here's another problem. What about when we have more developers um, or more development stages? So we don't necessarily want our development environment configuration to slip into production, much like we don't want our test one to slip into production. Maybe our development uses some sort of local SQLite database, while production uses a hosted PostgreSQL, and maybe development enables extra logging that production doesn't, and this is where profiles can come in. So we can have a dev profile and a prod profile. And we tell Spring only use the configuration when the dev profile is active. So then we would simply annotate, and you're going to notice that annotations are a thing with Spring. You can conditionally register beans with at profile. So that at bean we made earlier, yeah, we can slap a profile on that and run this bean on this profile. Now your application can behave differently depending on the environment that it's running in. Same application, just different environments. Now, we've also reached the part where beginners usually say, okay, but Spring Boot is magic. And I understand why they feel like that. But you add a dependency, you write Spring Boot application on the first main class, and you run the application. And suddenly, you've got a web server. You didn't even create the server. You didn't manually configure every component, but something happened. This is Spring Boot's auto configuration. Spring Boot looks at what's available in your application's class path and configurations, and it then tries to configure sensible defaults for you. For example, if you add the appropriate web dependencies, Spring Boot will configure an infrastructures needed for web applications. And this can all be started from that annotation on the main class at Spring Boot application. Now, which also includes the auto configuration mechanics. However, there is one more thing. I don't want you to think Spring Boot just knows what I'm doing. It doesn't. It follows a predefined set of rules. Spring Boot's auto configuration is heavily based around conditions. So you may see things like conditional on class, meaning only configure this if a particular class is involved. Or maybe you'll see conditional on missing bean, which is just saying if the developer hasn't provided their own version, I'm going to provide my own. Maybe you might see conditional on property, which means only enable this configuration if a particular property says we should. And this is the part that makes Spring Boot feel intelligent, and it's really a collection of carefully designed conditions. And that's why adding a dependency can suddenly cause Spring Boot to configure a whole bunch of infrastructure and feel like magic. So here's a little trick that I want you to remember. If Spring Boot is doing something and you're thinking, where the hell did that configuration come from? Don't guess. Start the application with debug information enabled. Spring Boot can provide you a con it can provide a conditions report. So it's going to show you which auto configurations matched and which ones didn't. And then suddenly magic becomes mechanical work. And once you understand the mechanisms behind it, Spring Boot becomes a lot less intimidating. So let's put all of this together, and our customer opens up the website. They see Midnight Cafe. They see options for tea, coffee, pastries, breakfast, lunch, and they go through and choose a few different items, and they put them in their order. And the request comes through into our web controller. The controller depends on the order service. The order service depends on the product and order repositories. And those repositories talk to our database. Meanwhile, Spring manages the relationships between all of these components. And that's the first time our little cafe project starts looking like an actual application. So let's start thinking about where we started. Our first conversation, we were just learning about Java, different variables, objects, classes, loops, generics. Then we talked about data, how we can organize it, lists, map, trees, graphs, algorithms. Then we gave our application somewhere to store that data, a relational database, SQL, transactions. And now we've got a web application in front of it all. And Spring isn't replacing those things. That's the part I really want you to understand. Spring isn't Java. It's a framework built on top of Java. And its job is to help us manage the complexity of a larger application. IOC gives us the framework control over object creation, dependency injection, connects those objects together, and the application context manages our beans. Configuration keeps environment specific values outside of our business logic, and profiles let us change behavior between environments. Auto configuration gives us sensible infrastructure without forcing us into configure every little detail. But we're not quite finished yet. Our customer can visit our site, they can see our products, and eventually they can place an order. But now we have another question. How does HTTP requests actually become a Java method call? What exactly happens when somebody clicks place order on the website? What does that request get in? How does that request get into Spring? How does it return HTML? How do we build a REST API? What is a REST API? And eventually, how do we let our desktop application and our CLI application use the exact same backend? And that is where we're going next. Because at this point, we've got a business, we've got a database, and we've got Java. Now we've got Spring. Keep your curiosity open, your skills sharp, and I will catch you in the next meetup.